Hi everybody, my name is Nathaniel. Today, so my talk is going to be a little bit different than Paul's. Instead of something super useful that you can go and use right away, I'm going to be talking some sort of more experimental stuff that I've been doing lately in Ruby. I'm curious, I know a lot of people when working with GraphQL tend to use JavaScript, but who here works in Ruby? Anybody? Okay, two. So this is going to be mostly interesting to those folks, I guess, but still this is stuff that can be abstracted into other languages. It's sort of more like an ideology. Who here is familiar with the concept of schema stitching? Okay, about half. So I am going to briefly cover what it is and what it means. To go over an overview of what I'm going to be talking about, I'll start just saying a few words about me. Then, as I said, I need to summarize schema stitching before we can go too far. I'm going to talk about what remote loading is, the thing that I'm working on right now. Apparently there's a thing in JavaScript that's also called remote loading. I don't know if it's similar or the same as that, but I might need a new name. Then I'm sort of going to dive into some technical details, how it works. To start, I'm going to talk about the GraphQL batch gem, what it does and how it works. Then diving into the remote loader, features, technical implementation, and what I want to do with it in the future. An example app that uses it, and then a little bit of time for questions and discussions. So just to talk about me a little bit, I am an engineer at GitHub. I've been working here for about a year now, a little over a year. At GitHub, I'm primarily working in GraphQL. For the last year, I've been working on the team that maintains our GraphQL API. So more of my work has been around developing tooling and the infrastructure around our GraphQL API. But about a month or two ago, I've moved on to a more feature-driven team. So I'm starting to develop schemas and build features in GraphQL. What else? I went to Waterloo. Anybody went to Waterloo here? Water, water, water. Hey. Yeah, I went to Waterloo. I only did a year there, and then GitHub tempted me away. But it was great. I live in Ottawa now, which is where Shopify's HQ is. People ask why I chose Ottawa, because I work from home, and I grew up in Cambridge, Ontario. And the answer is it's a nice enough city and it's far enough away from my parents. So it works for me. And it's a nice place. If you haven't been, you should visit. Okay, so schema stitching. Let's talk a little bit about that. So one of the really nice things about GraphQL is that, it gives your front end a single interface to fetch data from. Your front end doesn't have to be concerned about what APIs this data is coming from. Is this data in MySQL? Is this database in Elasticsearch? All that. What upstream providers, what services is this data coming from? To your front end, it's all a GraphQL API that defines the schema. The schema defines what data is available, and the front end queries for data. It's pretty straightforward. The front end doesn't need to know about how that data is stored. But what happens if, say, some of that data is stored in another GraphQL API? Either you have services that have a GraphQL API that you're pulling data from, or maybe even your front end needs to pull data from a third-party GraphQL API. I know there's a GraphQL API that you can use to fetch the weather, which is kind of cool. Stuff like that. So in cases like that, you can fetch data from multiple GraphQL APIs, but that starts to defeat the purpose of creating a single interface. So we get into schema stitching, which is sort of the consolidation of multiple GraphQL APIs into a single GraphQL API. The implementation isn't super important because it can be done in different ways, but the important part is that to your front end, it's a single interface that exposes the data that's being sourced from multiple GraphQL APIs. Does anybody have any questions about that before we move forward? Okay. As a quick example, I stole this from Apollo. They have a blog post where they introduce schema stitching. So here we have two APIs. Let me get my laser pointer. Okay, so here, Ticketmaster Universe API, it provides an API for events that you can buy tickets for on Ticketmaster. This is, you're querying for an event, and this is the GraphQL Summit 2017. You can get some information about that. And then down here, there's a weather API where you can give it the name of a city, and it'll tell you the weather in that city. It's pretty useful. Say you're Ticketmaster, and you want to provide the weather for like what the weather is in the location of events in your API. And you want to power your front end with this API, maybe. Here, again, we're consolidating multiple GraphQL APIs. That's where schema stitching comes in. Your stitched API might look something like this. Again, the front end's only making one API request, but this schema that's defined is a stitched version of the two different APIs. And it's not even side by side. We're not fetching the city name for this event and then fetching the weather for that city name. You can see on the event type, there's actually weather fields. So it's meshing the two schemas together. Any questions about that before we move too far forward? Seems like everybody's on board so far. So this is schema stitching, taking APIs, blending them together, one API. So that's cool. Unfortunately, as far as I know, the only implementation right now that's fully production ready and used by people is in JavaScript by Apollo. I don't know if anybody knows of any other ones. I know there's some stuff that's sort of something, but from what I know, it's just Apollo mostly. And something happened recently at GitHub where we were extracting part of the website out of the monolith into a service, and it had a front end, and it wanted to power its front end with its own GraphQL API. But it needed some data from the github.com API. Again, this is a case where you might want to, the services API might be a stitch of its own data and the data from the github.com GraphQL API. Their service was written in Ruby, but there's no support for any of that in Ruby. So they rewrote the service in JavaScript, and now they use Apollo schema stitching. And I thought that was kind of unfortunate, so I set off on a journey to implement schema stitching in Ruby, and I realized it's really tricky. It's really hard, actually. And it took a big team of engineers at Apollo quite a while to do correctly. So I ended up narrowing my scopes a little bit, and I came up with another idea of how you might be able to achieve similar, how you might be able to solve a similar problem using a little bit of a different method. I said that. And so I created the GraphQL remote loader. The GraphQL remote loader offers tooling to make GraphQL queries from within the resolvers of a GraphQL API. So think of it as you have fields in the GraphQL API. In the resolvers, you're making GraphQL queries. That seems simple enough. Just every library has HTTP libraries. Just throw some, make some GraphQL queries. But I'm sure you can come up with reasons why that might not be a great idea. Say Ticketmaster events, every event has a weather field where you can fetch the weather. And they add a field that sends just an HTTP request to the dark sky weather API. And you make a query that's something like, I want the next 150 events, and I want the weather for each one. You're going to make 150. Their API is going to make 150 requests to the upstream API. So this tooling is all about the batching and the batching of GraphQL queries across different resolvers in your API. And I'll explain a little bit about how that works as we get into the technical details. Here's an example of what a really naive solution might look like. Again, think of the weather example that I was just talking about. So there's only 2 Ruby GraphQL people here, so I'm going to take a minute to explain the DSL and how this all works. This here is this field line gives information about, this is the metadata of a field in GraphQL. So here on this type that I'm in, this is just the query type. I forgot to put a file name, but on the query type, I'm defining a field called issue count, returns an integer, it has a description, and then this method below it with the same name is the resolver for the field. Here I've defined some method called query GitHub, which just sends an HTTP request, and I'm giving it a GraphQL query, and then it parses the JSON that it gets back from the API. So if I was to do that, and I made a query to this API, maybe asking for this information, I just want the issue count and I want the pull request count. The API would make an upstream request to the GitHub API with this, and then again with this. This is an example with 2 fields. It gets out of hand really quickly. So this is not an option. We can do better than this. Before I get too into how it works, I need to talk a little bit about GraphQL Batch, which is a gem that was created by Shopify a couple years ago, I think. GraphQL Batch allows the batching of data fetching operations across a GraphQL Ruby API. As an example, if multiple fields in your API fetch user records from the database, GraphQL Batch offers a way for these fetches to be batched together, which improves performance. It achieves this by introducing a promise-based API. I know JavaScript these days is very promisey, but Ruby isn't. If we go back to this example, we have a method here, and it returns a thing. That's how Ruby typically works. We don't have a native concept of promises in Ruby. GraphQL Batch changed that for GraphQL Ruby in specific, and it introduced promises to achieve data batching. So it might look something like this. This is a resolver. This loads categories for a given shop ID, and then when it eventually does load the categories, it does a thing. This loader returns a promise, and what a promise signifies to the GraphQL engine is if a resolver returns a promise, move on, go execute something else, and then when there's no other fields left to resolve, come back. The loader will do its loading. It'll load all the records as efficiently as it can, and then it'll yield to these blocks. Does anybody have any questions about that? Yep.
Is that a thread in Ruby, or how do you do async?
It's actually not threaded.
Process or something?
Yeah, it's all like single thread. No. So you can think of the GraphQL engine. It has a list of fields that it needs to process. It starts at the top of the list, and if it returns a promise, it just sends it to the back of the list, and it'll process everything it can until there's nothing left. And then when there's nothing left but promises, it'll tell the loader, hey, I need you to do some work now.
So it's a virtual event.
Essentially, yeah. I don't know too much about how GraphQL Batch is actually implemented, but it sounds something like that.
Cool.
Yeah. Any other questions about that? Okay. So this GraphQL Batch. That sounds super useful for what we're trying to do, because we want to send GraphQL queries in our resolvers, but at the time of the resolver, we don't know everything that we need to send to the upstream API. So maybe we can do something like this. As an example, this is a little like a reason why you should use GraphQL Batch if you're doing a GraphQL API in Ruby. This query, this GraphQL query, fetches the first 20 followers, then gets the repository count for each one. Without batching, you would get SQL queries that look something like this, because for each user in this list, you're going to ask for the repository count, and if you do that synchronously, you're going to end up with 20 select count queries to your database. With nested GraphQL, that can, like 20 can become 400, can become 20,000 really quickly. And when that happens, you either break your database or your clients end up waiting 30 minutes for a response, and I think neither of those are acceptable. With GraphQL Batch, it might look something like this. No SQL queries are fired until the batch loader knows everything it needs, and then it might send a SQL query that looks something like this. this SQL basically says, fetch all the repos that are owned by any user in this list, and then create essentially a hash mapping owner to a count of repositories. It's a super efficient way to do it in SQL, way more efficient than making 20 SQL queries, way less overhead. And then the GraphQL batch engine resolves each promise with the data that it asked for. So with that, I think we have the appropriate background knowledge to dive into the remote loader and how it works. It looks something like this. So we have, here I've named it GitHub loader. This is just a GraphQL batch loader. You give it a GraphQL query, and then you do things with the data that it gives you. This syntax is very, very similar to the syntax that we saw before with the GraphQL batch, because this is just a batch loader. It's a batch loader that accepts a whole bunch of GraphQL queries, and then when it's time to resolve, it groups them all together, sends a single GraphQL request to the upstream, and then splits apart the response JSON and resolves each promise with the data that it asked for. Here you see if you were to send this query to this API that's using the remote loader, it might send a query like this to the remote API. It's a single query that's batched this data, or this query, and this query together. It'll get a response JSON, then it'll split them apart and only give the data that each one asked to each block. So again, it provides a GraphQL batch loader. Then when it has to resolve, it merges all queries into a single GraphQL query, executes the query against the remote API, splits apart the response JSON, resolves promises with the appropriate promise, or with the appropriate response. Now, next I'm going to dive into how each of these steps works, because some of them are a little bit interesting technically. Anybody have questions so far?
Just to make sure, that's it for every remote, right? That's all the steps for per remote.
Sorry, could you?
So that's all 4 steps per remote, right? Yeah, obviously.
Yeah. If you have multiple different remotes, then it's going to need to do a query for each one. Yeah. Okay, so let's dive into it then. First, I'm not going to explain this step because this is all GraphQL batch, like accepting all the queries. The interesting stuff happens when when GraphQL batch tells us, okay, it's time to do your work. So the first thing we need to do is merge queries into a single query. I thought instead of explaining, like giving a big block of text about how those rules work, I would just give a bunch of examples. So a simple example, we have 2 queries, query viewer ID, query viewer login. You can merge them like this. Notice we're not fetching viewer twice, not query viewer ID, viewer login. That would cause a name conflict, but also depending on the implementation of the upstream API, that might be less efficient. You could alias to make that work, but it might be less efficient. So we try to merge when we can. When fields have like arguments and 2 different queries ask for selections, we can merge those. There's no problems there. But when fields have unlike arguments and they have the same name, here both fields are called user, we need to introduce aliases to prevent naming conflicts. We do the same thing with directives. Directives can have arguments, and if the arguments don't match, then we need to alias to prevent namespaces, to prevent namespace errors. At this point, I got really sick of copy and pasting pictures of code. So there's other things that it does. Fragment definitions, inline fragments, aliases. The queries that you provide to the loader might have aliases. So the merging system needs to keep those. It can't destroy the aliases because the block that you provide to handle the response is going to be expecting the response JSON to be keyed by those aliases that you provide. So we can't destroy the aliases. All stuff like that. That's how the merging works. It's just a big list of rules that parses the GraphQL tree and merges things together. The next step, executing the query. We have to remain agnostic here because we don't know what the upstream server is like. It might be on the web, it might be on the same machine, it might be accessed over RPC if it's like internal or something like that. So to use the remote loader, you define your own loader that subclasses the loader that we provide, and you define a query method that takes a query string and it somehow sends it to your server. We don't care about that. It somehow resolves that query and returns a response. The response just needs to be something that is a hash. So in this case, this GitHub client is just, it's using the GraphQL client gem, which is a Ruby package for querying GraphQL APIs. So your implementation for querying the upstream database might look something like this. This could also just be a straight up HTTP request. I guess maybe you could, never mind. Maybe you could query this database that you're running on right now. I don't know what the use case for that is though, but maybe. Next, we need to split up the response JSON. So we've merged all these things together into a single query. We've sent this single query to the upstream and we get a single response, but we don't want to just return this single response to each promise because A, there's going to be data that they didn't ask for, and it's just going to complicate things if it needs to expect things that it didn't ask for. Also, well, there's also the case of, I think the first point, aliases. The gem applies aliases that the caller of this loader isn't going to expect. Remember, naming conflicts, we need to alias to prevent naming conflicts. So the gem needs to undo those. There's also the thing where there's an errors top-level key in GraphQL that includes errors that occurred during execution. And we don't want to include errors that occurred on fields that weren't requested by a specific caller. Because then, like a simple way of checking for errors is, are there errors? And if there's errors, do something. It would be really misleading if we included errors that happened on fields that weren't asked for by the caller. Thankfully, the spec includes a path and a location on the error object, which tells what field the error occurred on. So we can remove errors if we can filter errors based on that. Now, the stuff that I talked about with merging wasn't 100% true. It's actually more complicated than that. Hello? Okay. So the gem actually applies aliases to absolutely everything to avoid conflicts. And these aliases that it attaches to everything is used in splitting up the response JSON. Because without it, it's a little bit tricky to do that correctly. And the aliases help with that. So how that works, this is where things get a little bit weird. So we merge by A, we assign each caller an integer, a unique ID. So first caller gets 0, second caller gets 1, etc. Then we just prefix each field with a bitmap alias. So here, that's very confusing. Here, this first caller is assigned ID 0. I'm using bitmaps, so say it's assigned ID 2 to the 0. Then I just prefix every single thing that it asked for with its ID, which is 1. And if multiple things ask for a thing, we sum their IDs. So here, ID 1 and ID 2 both ask for viewer, so we prefix it with 3. Only number 1 asks for ID, so we prefix it with 1. Only number 2 asks for login, we prefix it with 2. This is ID 4, not 3, because we're working with powers of 2. So only 4 asks for user, only 4 worked with ID. Now, why would we do that? That's pretty confusing. And it seems like unnecessary complexity. But A, that's free namespace collision handling. We don't need to do anything around handling naming conflicts. But also, when we get this response JSON and we're trying to figure out which promises own what, we just convert these numbers back into factors of 2. And so this is 2 to the 0 plus 2 to the 1. And 2 to the 0 plus 2 to the 1 includes 2 to the 0. So ID number 1 asks for that. It's just math. The actual implementation right now, this is what I'm going to do very soon. Right now it's using prime factorization. So every caller gets a prime. So this would be like 2, this would be 3, and then they're just multiples of primes. So this might be 6. And if the ID is divisible by a caller's prime, then it asks for it. I was a math major. That was the first thing that came to mind, but then I realized bitmaps were way less, they require less space, less data. So I'm going to move to that. Does anybody have questions about this? It's pretty confusing. Yeah?
You couldn't use Git in this instance, right?
I couldn't use what, sorry?
Git protocol.
Git protocol. Git protocol for what exactly?
Git implementation. You know, like Git as in GitHub.
Yeah.
Like, because you're comparing things and you get hashes out of the box of Git, and you know where you could find commonalities. You could.
Yeah.
I think working at GitHub, you might. I don't know.
Yeah, we could have done something fancy with Git, but it's just another dependency.
It might be too big, right?
Yeah. The nice thing about this is that it's very like space efficient. So that's mostly why I chose it.
Cool.
Yeah. Any other questions about this? Okay. So now we've done this. We send off this query with our aliases. We get the response JSON, and then we just split based on the numbers. Remember, this is ID 0, this is ID 1, this is ID 2. We do our powers of 2 factorization to figure out who owns what. We remove this. Also, the reason that these are prefixed with P is because GraphQL says aliases can't start with numbers. So I had to throw something there. So we remove the alias prefixes, and then we just resolve each promise with what it asks for. And the response that each promise gets looks something like this. Notice that the promises, they have no idea that this query that they sent to the upstream API was shared with other callers. It's sort of like a shared virtual machine. The user on the virtual machine should have no idea that it's sharing resources with another server, with another process. From its point of view, it is the only thing in the world. And that's how it works with the remote loader. Okay, so that's the remote loader. That's how it works. Now, just to take a step back, what were we trying to do initially? Think of the weather example that we talked about earlier. To do this with remote loading, instead of stitching 2 APIs together, Ticketmaster might add a weather field to their event type that has a remote loader call that just asks for the weather in a specific city. That'll all happen asynchronously. It'll get the response. It'll return the response. And that just works. That's kind of the idea. It solves similar problems as schema stitching, but it's a lot less complex. Schema stitching has only ever been implemented by Apollo, at least successfully in production. That kind of tells you how complex it is and how many crazy edge cases you need to solve. This is pretty simple. So if you don't need the full power of schema stitching, this is sort of an alternative to solve similar problems. Now, I'm going to go through a quick little example application that I wrote up to show how it might work. This app does run. So this is it on GitHub if you want to look it up. My handle is D12. It's called the GraphQL remote loader. You can find it on my GitHub. Example application. Okay. So this is just a simple little GraphQL API that it tells you you give it a GitHub token, and then it tells you your login, your issue count, repository count, pull request count, and it tells you if you're famous. Pretty straightforward, but what it's meant to be is it is a GraphQL API that requires data from another GraphQL API, which is exactly the problem that we're trying to solve with schema stitching. So there's 4 relevant files that I'm going to go over really quickly that show how the remote loader is used in an app. This is the query type. Let me make this a bit bigger. Okay. This is the query type. Lots of comments. Here's a login field that fetches the currently authenticated user's GitHub login from the GitHub API. Again, it's just sending the GraphQL query via this GitHub loader that I've defined. And in a second, I'm going to show how the GitHub loader is defined. It's sending this query, and then it's returning this thing. If there's errors, it'll nil out. That's all this does. This is famous field is a little bit more complicated. It sends a complex query that asks for the number of followers that the current user has. It asks for the first most starred repository that the user has, and it checks how many stars that has, and that's it. It sends that query to the upstream, and then it does some processing. We just return nil if we got errors. We get the follower count, we get the star count, and then if they have more than 5,000 followers, or if they have more than 5,000 stars, we define them as famous. And that's how that works. The other fields are the exact same. They just do the same thing. For a query that was to fetch all these fields, they're all batched into a single GraphQL query that gets sent up. Let's see. There's a couple other fields, or a couple other files. The GitHub loader. So this GitHub loader is going to look pretty similar to the one that I defined earlier. Oh, actually, it's the exact same as the one that I defined earlier. We're just using GraphQL client. So I defined a loader that subclasses from the remote loader. It parses the query, sends the query to GitHub. This GitHub client is a GraphQL client thing, and I will show that in the next file. This is our application configuration. So here I'm defining how to query the GitHub HTTP server. So this is the URL, and it sends these headers. It just grabs the authorization token from your environment. I define this GitHub client using the GraphQL client gem, and that's it. Also, it is important that you allow dynamic queries because, well, that's a GraphQL client specific thing. I explain that in the README. One last thing. What is this? Oh, that's again, just an implementation thing. Because we're using GraphQL batch, you need to use it in your schema file. That's just a Ruby thing. Let's see. But yeah, that's it. That's the remote loader. That's where we're at right now. There's some more work to be done. Let me take a look at the issues. Anything interesting that I want to do in the future? Oh, too far. Got to do that. Validation. As you could tell, you're just passing like GraphQL strings into the loader. It would be pretty cool if we could type check that syntactically and like type checking. Right now, that isn't a thing that happens. It'll just error when it goes up. So that's one thing that I need to work on. The integration tests. I guess there's nothing super interesting coming up. That's it. Yeah, thanks for listening.